Not all pyramids were perfect. Before the gleaming perfection of Giza's Great Pyramid, there was a time of trial, error, and innovation. Monumental mistakes were made, some nearly catastrophic. But each failure led to new insight, and those insights culminated in one of the greatest architectural achievements in human history. One such turning point was the construction of the enigmatic Bent Pyramid, a strange, beautiful monument that still stands today, half angular and half sloped, like a monument caught between two decisions. But before we explore what went wrong, let's understand how the Egyptians even began experimenting with such daring structures. From steps to slopes, a new vision of power. The earliest pyramids were not the smooth-sided giants we recognize today. The very first pyramid, the Step Pyramid of Djoser at Saqqara, built around 2600 BCE, was more of a stacked mastaba, a tiered stone structure rising 204 feet from the desert floor. Designed by the famous architect Imhotep, it marked a revolutionary shift, the world's first monumental stone building. This step design evolved into a new ambition, a true geometrical pyramid, smooth-sided, elegant, and symbolic of a perfect connection between heaven and earth. It was Pharaoh Sneferu, father of Khufu, who would take on this challenge. He built more pyramids than any other pharaoh, refining the technique through both failure and success. And nowhere is this process more evident than in the Bent Pyramid at Dahshur. The Bent Pyramid, a beautiful mistake. On first glance, the Bent Pyramid appears elegant, until you notice the sudden angle change halfway up. Its lower half rises at a steep 55 degrees, but midway, the slope suddenly softens to 43 degrees. Why? According to archaeologists Maragioglio and Rinaldi, who extensively surveyed the pyramid, the structure was built on unstable clay and sand, with only its outer edges resting on solid rock. As it rose, the immense weight began to destabilize the core, threatening a total collapse. This posed a dire challenge: either abandon the project or find a solution. Egyptian engineers chose innovation. They abruptly reduced the angle, flattening the top portion to relieve the stress on the base. The pyramid ended up shorter by nearly 100 feet and lighter by over 400,000 tons. Though it no longer matched the original vision, the structure held. Over 4,500 years later, it still stands, bearing silent witness to a mistake turned into success. Engineering wisdom in stone. The Bent Pyramid was more than just a mistake. It was a lesson carved in limestone. It revealed the importance of choosing the right foundation, the right angles, and the right distribution of weight. Sneferu's architects learned from the ordeal. Their next project, the Red Pyramid, would be a careful, cautious response. Built at a conservative 43-degree angle, it remains one of the best preserved pyramids in Egypt, and it was the first successful smooth-sided pyramid in history. With this success under their belts, Egyptian architects began pushing the limits once more. Their crowning achievement? The Great Pyramid of Giza, Khufu's monument to eternity, built at a refined angle of 51.8 degrees, standing nearly 481 feet high. But how did they get massive stone blocks to such incredible heights? Lifting the unliftable. The ramp theories. As the pyramids grew taller, one critical question loomed larger. How did they raise stones weighing 2.5 to 15 tons to such heights, without cranes, pulleys, or iron? Most Egyptologists agree that the answer lies in ramps. But what kind of ramp could handle such an epic task? A straight-on ramp from the ground to the top would have required an absurdly long stretch, over a mile, using more materials than the pyramid itself. A zigzag ramp, climbing back and forth up one face, would reduce this bulk, but add complexity and reduce visibility. A spiral ramp, wrapping around the pyramid like a corkscrew, would offer compactness, but limit precision when placing final capstones. Archaeological evidence for any specific ramp system is scant, likely because they were dismantled after construction. Yet fragments of rubble, sloped roadbeds, and alignment trenches hint at a combination of these methods. Some experts suggest the ramp system evolved with height, beginning with a straight or zigzag base ramp, then transitioning to an internal or spiral system higher up. The exact truth remains elusive, but the mathematical foresight and human will required to execute any of these theories remains breathtaking. The forgotten genius of the builders. It's easy to marvel at the monuments and forget the minds behind them. The trial and error process that led to the perfection of the Great Pyramid was not built on divine intervention or alien technology. It was built by thinking humans. They learned from failure. They experimented. They recalculated. They respected their materials. And perhaps most importantly, they planned for permanence. We know this because no major pyramid after the bent pyramid was ever built at such a steep angle again. The caution learned from Sneferu's near disaster became a golden rule. That kind of institutional memory, passed down through generations of builders, is rare even in modern corporations. But ancient Egypt had it, and they used it to great effect. The final form, pyramid geometry and stability. Why the pyramid shape at all? From a purely structural standpoint, the pyramid is incredibly stable. Its broad base and tapering sides create a low center of gravity, distributing weight evenly downward. Over 2/3 of its mass lies in the lower third, anchoring it deep into the earth. But structurally sound doesn't mean easy. The pyramid shape also required perfectly aligned corners, evenly laid stones, massive labor to maintain level floors at every tier. And yet they achieved it again and again, over 500 years, constructing at least 18 major pyramids and dozens of smaller ones. The learning curve, visible through trial and error, is itself one of the most astonishing records of engineering evolution in antiquity.